Hi everyone, welcome to another video. Now, we are talking today about a brand new part of this function topic that we've introduced in the last couple of videos. And this is the idea of function notation. So we're introducing a brand new concept, something called a function. And since this is something brand new, we want to come up with our own ways of writing this, giving it a unique presentation so that we can consider the ideas that we've learned up until now. So we introduced this idea of a function as something that we've been kind of doing this whole time without realizing. We looked at the idea of a linear relationship, for example, y equals 2x plus 1. And we said that this is, in essence, what we've been doing with functions. We put in some kind of input, think back to when we did our table of values, and we got out some output of y. Now, we're talking about this same thing throughout this video, but now we're just going to introduce some kind of notation, some kind of way of writing this that really nicely shows my idea of functions here. Now, let's just once again consider this idea of some kind of function machine where we're putting in some value of x and we're getting out some value of y. But now instead of y, I'm going to write the type of notation that we're going to use for functions. And this is the idea of f of x. We write this as f of x. That's what this means. So this thing is still our output, and my x here is still my input. So looking at this kind of notation here, f of x, I have my thing that I plug in, which is still going to be my x, so the input, and what I get out is my f of x. So in other words, the f of x is exactly the same as, for example, the y when we looked at the example from linear relationships. Now we're just using a different type of notation to show this. And you're going to see in some later examples how this can make it easier to maybe work with this idea of inputs and outputs. So let's look at these examples now, and hopefully by the end of this video we will realize that this f of x thing isn't too scary, because this is what gets a lot of students. A lot of students find a lot of issues in dealing with this idea of a new thing, this f of x. But it's really, in essence, the same thing we've been doing so far. Now let's consider some kind of equation. So for example 1, we have that instead of y now, we're going to put f of x. This is some kind of function equals x squared minus 3x plus 1. Now we remember that this particular thing here is a quadratic. So this is kind of like this is essentially the equation of a parabola, where there's some input y, or we're going to call it now f of x using our new notation. And we're going to look at how we can work with this particular notation. So for part A, we want to find f of 0. So what this is telling me here is that instead of x now, we're going to put in an input of 0. So let me actually write that in here. So we are inputting 0 in place of x. Now you can think of this thing here as the input going into the x's is just x. But now we can find different values of f of x or different values of y, because this is the same thing we've been doing, and we can just substitute in different types of inputs. Now in this case, my input is going to be 0. So my f of 0, or my function f of x when x equals 0, or the output when my input of x equals 0, is going to be, now in place of all the x's, I'm going to put a 0. So I have 0 squared minus 3 times 0 plus 1. Now 0 squared gives me 0, 3 times 0 gives me 0, so I'm just left with 1. Now let's look at another example. We want to find f of minus 3. In other words, we're finding the output, the y value, the f of x value, when x, my input, is negative 3. So I'm going to input negative 3 in place of all of my x's. It's just simple substitution. It's what we've been doing this whole time, all the way back to linear relationships. But now this is going to give me minus 3 in place of the x, all squared, and then minus 3 times minus 3, and I have plus 1. Now, negative 3 all squared gives me 9. Minus 3 times minus 3 gives me positive 9. And my 1 stays. And I am left with 19. Now, let's do one final example here. And I'm going to throw a little weird spanner in the works. Here we've been substituting in numbers. What happens if I substitute in, or if I find f of c, when my x value is just some other random number, just given by a pronumeral of c? Well, in the same token, we are just putting in a different input. Now, instead of 0 or negative 3, like these last two examples, we are putting in c in place of x. So whether this is a pronumeral, whether this is a number, my function notation just tells me my output f of x for different inputs of x. So now the input here is going to be c. So I'm going to do, in place of the x, I have c squared. I have minus 3 times c. Let's actually do brackets around these. And plus 1. So I just get, I don't know what c is, so I'm just going to write c squared. Minus 3 times c just gives me minus 3c. And I have positive 1 at the end. So all we are doing with all of these things is we are inputting some x, some value of x, and getting out. Now, sorry, let's write here, let's just make a note. The value of x here is my input. I'm putting something in, and we are getting out some value of f of x, where this f of x is my output. So nothing's changed from when we first introduced functions. We're still putting something in and we're getting something out. It's this idea of my function machine that I drew up here. Something goes in, something else comes out. And now we just have a blanket kind of umbrella notation of f of x, which we can use for any function. We're no longer thinking of this as y and x. We're introducing a new notation that makes it easier to deal with functions, that gives us a unique way to write notation for just functions. Now, not all graphs are functions, so it's important here that we have some kind of notation for this, and function notation gives us this way of looking at these.